Hello and welcome to the Bearded Math Man's YouTube channel. Hey, I'm glad you guys are here. If you are struggling to figure out how to factor something like x to the power 6 minus 2x cubed minus 35, you're in luck. This is the video for you. This is a trinomial and it's in something called quadratic form. I'm going to teach you today in this video what quadratic form is, what it is not, and then teach you how to factor trinomials that are in a quadratic form. So let's get to it, shall we? First of all, what you're going to see on the screen right now, few examples of trinomials that are in quadratic form. Now you might be sharp and say, well, wait a minute, that's a binomial, but it still could be considered a trinomial because you could do plus 0 and it is in quadratic form. Now, give yourself a second. There is a relationship between the exponents. In all of these, it's the same. That makes them in quadratic form. Do you see also that they all have a constant term? Do you see all of these end in a constant term? Plus 0 is constant. There's no x at the end. So this is kind of similar to a quadratic equation, ax squared plus bx plus c. Do you see? So here's the deal. This right here, this leading coefficient, or this degree right here is going to be double of the second exponent every single time. And that's what makes this a trinomial in quadratic form. So let's think about this in a couple of different ways. Do you see how this is x squared? Well, if I squared that x squared, well, you double that. That's to the 4th power. Same thing here. If I took 4 and I multiplied by 2, that exponent of 4, if I squared x to the 4th, you would have to multiply 4 times 2, you get x to the power of 8. So here's the deal. If you have a trinomial, that means it's got 3 terms, right? Single variable. If the third term is constant, the degree is even, and the degree is double of the second exponent, you have a quadratic formed trinomial. Now, the reason that the degree is going to be even is because whatever this second exponent is, when you square this, it's doubled. So any integer doubled is going to be even. So there you go. Let's see a couple of non-examples. Here's one right here. X cubed plus 8x squared plus 16. Now it is a trinomial. Yes, for sure. It's cubic, but it is not, for sure, for 2 reasons. There are 2 reasons this is not in quadratic form. The first reason is if you square x squared, you get x to the 4th, not x cubed. Do you see? So this would have to be 4 if this was a 2, right? The other reason, right off the bat, this is odd, right? This is an odd exponent. So for polynomials, we're dealing with polynomial functions over here. The exponents are all going to be whole numbers, no fractions, no irrational numbers. So the only way that this could work is if this was 3 over 2, because if you square 3 over 2, you get 3. So no dice, right? Now, this one, if this 2 was a 3 instead of a 2, if this was a 3, this would be in quadratic form, but it's not. Do you see? So half of 6 isn't 2, it's 3. And 2 squared isn't 6, it's 4. So for 2 reasons that doesn't work. That relationship has to be there. This exponent, this term has to be squared of this one. So if I had x squared as my b term, well, the first one would have to be x to the 4th. Do you see? If the first term was x to the 6th, this would have to be x cubed. Yeah, there we go. Now, let's get into factoring, right? Easiest kind of quadratic equation to factor would be where the leading coefficient is 1. So for example, if you had x squared plus 5x minus 50, well, all you'd have to do is figure out, well, what 2 numbers multiply to 50 and the same 2 numbers add to make 5. Well, for quadratic formed trinomials, so a trinomial like this that's in quadratic form, we use the same exact techniques to figure out how to factor. So here a is 1, so this isn't x squared plus 5x minus 50, it's x to the 6th plus 5x cubed minus 50. We're going to use the same exact thing. We're going to figure out what 2 numbers multiply to 50, negative 50 that is, add to positive 5, well, that's going to be a 10 and a negative 5. And we could check it if we wanted. And let's do that just to make sure that the exponents are working out right. Do you see if I multiply these first 2 together, x cubed times x cubed, well, that's x to the power of 6. So we're good to go. The outside, well, that's negative 5x. The inside is plus 10x cubed, and then plus 10 times negative 5 is negative 50. So negative 10x, or negative 5x cubed plus 10x cubed, well, that makes up plus 5x cubed. So there you go. It works just fine. Now, what if you had something like this? A is not 1. Oh, man, and this also, if we look, this is not a trinomial that's in quadratic form. It is a trinomial, 1, 2, 3 terms, but it's not quadratic form. So, man, it might still be factorable, but we have to be careful. So look, if you notice, you can take out a 3x. If we take a 3x out of all three terms, you're left with x to the 6 minus 3x to the 4, 3x cubed minus 4. So 3x divided out. So 3x times x to the 6 minus 3x cubed minus 4, same thing, right? So this is factorable. Now, before this lesson, if you didn't know what a trinomial in quadratic form was, you couldn't factor this. But this is a trinomial in quadratic form. I keep mixing those two up. Man, it must be a Monday. It actually is a Monday. What is it? It's Monday, and we're in the middle of quarantine. It doesn't even feel like Monday. I don't even know if it's Monday or June. All right, sorry about that. Let's get back on track. So check this out. This is a trinomial that's in quadratic form because, do you see the relationship between those exponents? If I squared x cubed, I get x to the 6. This degree is double of the second one. The second exponent is half of the degree. That's the relationship you need. That's how it works if you have a regular quadratic like x squared minus 3x minus 4. All right, so we're going to factor this right here. So we're looking for two numbers to multiply to negative 4 and add to negative 3. Boom, we got them. Do you see? Now you do have to be careful here. Check this out. You should know, at this point, you should know how to factor the sum or difference of cubes, and you have to watch out for those. This right here, not done. This is the sum of cubes. X cubed is a perfect cube. 1 is a perfect cube. So you can factor that a little more. If you don't know or you forgot the formulas for the sum or difference of cubes, I'll leave a link in the description below. You can check it out. And that way you can be rock solid on all this, right? All right, let's see a couple more examples. This is the trickiest one right here. Man, this is a trinomial in quadratic form because x to the 4th squared is x to the 8th. Oh, man, but a is not 1, it's 10, and I can't factor out. The leading coefficient isn't 1, I can't factor it out. So this is where factoring gets really tricky. Now, depending on where you learned and what level you're at, you might use all kinds of different sorts of factoring tricks or techniques. My very favorite to this day is still guess and check. That's where you guess the factors of 10x to the 8th, and you guess the factors of negative 3, and then you set them up and you just check the outside and the inside to see if you can get a negative 1. So here it is. Look, the purpose of this video is not to teach you how to factor a quadratic or the techniques for factoring quadratics. If you need help on that, check the description. There's links where you can go and learn how to do that better. The idea here is to teach you how to factor these, or to identify a trinomial that's in quadratic form so you can factor. And I just want to show you this factoring is exactly the same as if this was 10x squared minus x minus 3. It would be 5x minus 3 and 2x plus 1. Do you see? Now we could check it. Let's go ahead and check it. Let's go ahead and do that. If I were going to check it and I'm going to multiply this out, I'd multiply 5x times this, and then minus 3 times this. If I'm not going to use my FOIL shortcut, do you see? That's what I have here. If you distribute, that's 10x to the 8th. That's good. Plus 5x to the 4th. Minus 6x to the 4th. Well, 5x to the 4th minus 6x to the 4th, that's negative 1. X to the 4th. And then minus 3. Do you see? So boom, we are done. All right, let's see some of the odd things that can kind of come up. All right, so this one right here, this is a little tricky, right? There are a couple reasons why this is tricky. Initially, it's tricky because a is not 1. And so you might use the box method, whatever. I use the guess and check method where I see this first one right here. That tells me my first two terms in each binomial are going to be 2x to the 4th and x to the 4th. No doubt about it. And then the other term is going to be, well, factors of 45. So it could be 1 and 45, 3 and 15, 5 and 9. I don't really know, right? Here's what it is. You go through all the process and this is what you end up with. And once again, I didn't go through all the steps of how to factor a quadratic where a is not 1. You can use whatever method you like. It doesn't even matter. It always is going to work the same way here for you, okay? But here's where it gets a little tricky. Do you see this second factor right here? Well, that's a perfect square, x to the fourth. So is 9. That's the difference of squares. You can still factor this. So you always have to be on the lookout for that because it's going to come back and get you. So here's the moral of the story. Whole thing, right? A trinomial that's in quadratic form, the degree is going to be even, and its exponent, the degree is going to be double of the exponent for the bx term. The last term will be constant. It won't have an x, right? And you can use your favorite quadratic factoring technique in the whole wide world to factor these trinomials that are written in quadratic form. If it is factorable, your technique will work. Doesn't even matter what kind it is, but you do need to watch out for the sum or difference of cubes when you're done, or the difference of squares. Otherwise, if you're confident and competent with factoring quadratic equations and quadratic expressions, then this should be no big deal for you. All right, so I'm going to encourage you to check out my website, thebeardedmathman.com. There is all kinds of help there for you, all kinds of factoring stuff, notes on this particular topic, including homework. So give that a shot. The link's in the description down below. Give that a look. And if this video is helpful, please give it a like. Share it on social media. Subscribe if you haven't done so already. And I hope you guys have a great day.